Okay, so today what we're going to do is we're going to continue on with our study of determinants, and we're going to learn where determinants are used. And so, first of all, we're going to learn how to do things mathematically today by hand, and then on Monday we're going to bring in the netbooks and we're going to use GeoGebra in order to find the determinants that way. And so first of all, you're going to notice there's Cramer's rule, and that's what we're going to be talking about today. And Cramer's rule is actually named after Cramer, okay, Gabriel Cramer. And he lived from 1704 to 1752. So obviously you can see he didn't live a long time, okay, kind of younger there. At age 18, he was awarded a doctorate. So when you think about that, for some of you that are already 17, that would mean like you getting a doctorate next year, a doctorate degree. A doctorate degree is usually your terminal degree, which means you've pretty much done as much schooling as you can. So you basically start with like your bachelor's and then your master's and then your doctorate. Okay. At age 20, he was the co-chair of math at the Académie de Clavin at Geneva. So this is Geneva, Switzerland, by the way. So at age 20, he was a professor. So when you think of that, some of you have sisters that are close to age 20. That would mean that they are a college professor at the head of the math department. And then at age 30, he was the full head of the math department. So anyway, pretty smart guy, obviously. And so he came up with this rule, and this is what the rule does. It uses determinants to solve a system of equations. And so when we ended last chapter, we solved systems of equations, and you guys really didn't like that, it seemed to be. Okay, remember you had to use a lot of elimination, substitution. Well, this is a way that we can just use determinants, what you did yesterday, to solve that system of equations. And so what we're going to do is we're going to look at that on a scaled back view today. We're going to look at that with two equations and two variables, and then we're going to look at a few 3x3s. So how you find x is you're going to take dx, and d stands for determinant, divided by d. How you find y is you're going to take dy divided by d. And how you find z, you're going to take dz divided by d. So obviously you're going to use the d a lot, and then you've got to find dx, dy, and dz. Now that's not going to make a whole lot of sense now until we look at an example. And when we look at an example, I think it'll make a lot more sense. Okay, so let's go ahead and solve this by using Cramer's rule. Now up until this point, you had just used substitution or elimination. Well, now I'm going to show you something totally different. So I'm going to go ahead and let you write that down, and then we're going to start using some determinants.
Will this take up a lot of room?
You can fit it in there. You're just going to probably have to write to the left there. Yeah. Okay, so first of all, what we're going to do is we're going to find D. Now, how I find D? Remember, I can only take the determinant of what?
X.
I can only take the determinant of what type of matrices? Square. So if I look at this, this would actually be a 2 by how many? 3. So this isn't a square. So what I'm going to do is I'm going to restrict this down. I'm only going to be looking at 2 by 2s.
How do you know if it's
So
2 by 3 by just looking at it?
1, 2, 3. Okay. So I'm going to look, pare this down, so I'm only going to be looking at squares. And so if you notice here, if I cut off the equal to sign, cut off everything to the right of the equal to sign, do you agree I've got a 2 by 2? That's what D is. D is always as if you're covering up the equal to sign and everything after it. And so my new matrix will be 4, -2, 3, -5. So big D, that is always just going to be whatever's to the left of the equal sign. So now all I need to do is find that determinant. We learned that from yesterday. So from yesterday, I'm going to take this diagonal here, which gives me -20, minus this diagonal here, which is -6. So big D is what value?
14.
-14. Okay. Did you get it squeezed in there? Okay. So then now what we need to do is we need to find dx and dy. Do we need to find dz? No, because I don't have a z here. I only have an x and a y. So how we're going to do dx, okay, how we're going to do dx is, if you notice, I haven't used some numbers, right? And what numbers haven't I used? The equal sign. So I haven't used the 10 and 11. So if I want to find dx, I'm going to go to the x column right here. And the x column has the numbers 4 and 3, correct? I'm going to take 10 and 11, and I'm going to put those numbers in for 4 and 3. So my new matrix will be 4, or no, take that back, not 4. What did I say? The 10, thank you. 10, 11, and then -2, -5. So notice the other two numbers stayed the same in the y column. So now I need to find dx. So to find dx, I'm going to go ahead then and multiply on the diagonals. So I get -50 on this diagonal, minus, so my answer is -28, good. So that's dx. Now what we need to do is find what? dy. So can somebody guess what I'm going to do for dy? Same thing I did with dx except for? I'm going to put 10 and 11 in for where? The y's. What will I put first? What's my first column going to look like? 4, 3. Excellent. Nice job. And then 10, 11. So now all I'm going to do is find the determinant here. So multiply. And I get 44 minus, so I get 14. So now here's how I find the solution. If you remember, Cramer's rule stated that my solution is going to be an ordered pair, first of all, an x and a y, and I'm going to take dx, which is -28, divided by d, which is -14. And then I'm going to take dy, which is 14, divided by d, which is -14. So all I did here, if you haven't figured it out and you need to make yourself a note, this is what I did. And now all we need to do is calculate those. And those actually come out nice and neat.
It's an ordered pair.
Yeah, it's an ordered pair. And those come out nice and neat. So my solution is actually what? 2, -1. And there you go. So that's how Cramer's rule works on a scaled down problem. Now obviously in this problem it probably would be faster to use elimination or substitution. Okay, probably would be. But what we're going to do now is we're going to look at where Cramer's rule comes in really handy, and that's going to be in a 3x3. Now obviously it's going to take a little bit of work, and that's why on Monday I'm going to show you how GeoGebra can make your life a lot better. And we're going to solve this system of equation. Now trust me, we're going to divide and conquer, so I'm going to split this up so you don't all have to do each determinant. Okay, but we're going to solve this system of equations using Cramer's rule. So I'll let you go ahead and get that down. So the first thing we're going to do is we're going to find D. So this is what I want you to do. We're going to write down all of the matrices. And then what we need to do is I'm going to split it up. So like this group will find one, this group will find one, this group will find one, and that group and me will find the last one. Okay, so let's first of all write D. What do I get for D? What's going to be my first column? Good. 4, yep, and then 2, 2, 3, and then -2, 6. Good. And so if you remember from yesterday, if I was going to find that determinant, what would I need to do? Copy the first two columns. Good. So then now let's go ahead and write dx. Don't worry about writing those two columns down because you don't know what one you're going to do. So dx, can somebody tell me what you think dx is going to look like? Okay, that's going to be my first column. Very good. -1, 2, -2 will be my next column, and then 1, 3, 6. There you go.
How did you do that?
Now, once again, what we did there is we went to the x column since I'm finding dx. And in place of the 4, 2, 5, I put the numbers from the right of the equal to sign. Okay, so all I did is replace 4, 2, 5 with -5, 10, 1. Everything else stays the same. So now dy. What column am I going to replace? With the y column, so everything else stays the same. So we need a copy. The first column stays 4, 2, 5. The last column stays 1, 3, 6. The y column now becomes
-5, 10, 1.
-5, 10, 1. And then the next one we need to do is dz. What column stays the same?
The x and y.
The x and the y. So my 4, 2, 5 stays the same. And my -1, 2, -2 stays the same. And what does the third column become?
-5, 10, 1.
-5, 10, 1. All right, here we go. Small group over there and me, we are doing the purple. Okay, you guys are doing the blue, the dx. This group here, you're doing the green, dy. That group back there, you're doing the dz. Okay, so when you get yours done, okay, let me know, and we'll go ahead and put your answers up, and then we'll get our solution.
You don't get it?
Is it 1 times 10 times 2?
On which one?
Dang it, I got -15.
The top you got 28. The bottom
160.
should be 88 because one of it.
I have 83.
I got -8. One to the -8.
Okay, so
Oh, it's -2.
purple group, you got to determine it for me.
-55.
Oh,
That's not a.
purple group.
Or,
I got 3, 40.
I think it should be 55. Okay, what'd you get, blue group?
-55.
-55. What'd you get, green group?
165.
165. What'd you get, yellow group?
110.
110. Good. So then now our solution will actually be, in this case, it's going to be -55 divided by 55. That's going to be x. What's y going to be?
165 divided by 55.
165 divided by 55. And what's z going to be? 110 divided by 55. So our solution will be
-1.
3, 2. There you go. Okay. So kind of neat, different way to solve that system of equations. And believe it or not, there's still another way using matrices to solve this, and it's called reduced row echelon form. And it's something that those of you that go in to take pre-calc will learn about that, and the calculator is your friend on that one. Because pretty much with the calculator, you type in that matrix, hit a button, and it tells you what all the solutions are. So anyway, this is what you need to do for me. You've got page 195, 39 through 46. I want you to add this to your one from yesterday. Now, this is what's going to happen. On Monday, we're going to go through and use GeoGebra to solve the system of equations. And so you're going to be able to check your last two answers on this homework. Okay. So do the best you can. And then on Monday, we'll continue.